Hello, I'm Isabel Wood-Quinones, and this is Connor Tamke,
Hello.
my boyfriend. I'm going to be teaching him how to do one subject t-test in statistics today. Alright, so for this problem, Connor, wait, let me ask, how much knowledge do you have in statistics?
I have a little. I'm in an IT statistics class right now.
Okay.
I didn't realize it was statistics.
Okay, yeah, it's statistics.
I know like ANOVA. You know what
Oh
that
my
is?
gosh, I should have done an ANOVA then. Oh wow. So, essentially we are gonna be using a t-test to compare the sample mean versus the population mean. Do you know what sample versus population means?
Yeah.
Okay, I want to make sure we're on the same page.
I know what a mean is as well.
Okay, good. We're on a great track right now. Okay, so in this problem that I came up with, this is the blood pressures, right here, of a sample of 10 women aged 40 through 45. The population mean for this age group is 120. Is the blood pressure for this sample different from the population average? This data set is collected randomly and distributed equally. Okay?
Okay.
So these are all the blood pressures from different women, randomly selected and whatnot. And so in order to do this, the first step is to create... Oh, it's windy. Give it a second.
Stuff is blowing.
Okay. The first step is to create a hypothesis. So do you know about null and alternative hypothesis?
Yeah.
Oh, you do? Okay, dope. Give me
I don't know
some.
how much I remember.
Okay, well, just give me some anyway. So in this case, we are testing to see if the sample average is equal to the population average. So for the null hypothesis, which is HO, mu is equal to 120. So the average is equal to 120. And in the alternative hypothesis, mu does not equal 120. Cool?
Okay.
Dope. Okay. And mu is equal to the sample average. That's what that means. Okay. And so the formula for t-test is x bar minus mu over sample divided by square root of mu. Do you know what those those mean, like the variables?
No.
Okay, so mu is the sample average and it's seen twice. S is the standard deviation, which we will have to calculate because it wasn't shown in the problem at all. And x bar is the average of all the x values.
120.
No, that's not the average. That is the population average. So that would be the sample. Did I screw this up? Hold on, wait. Now I'm confusing
Isn't that the
myself.
mean of this?
No, that's the population mean, so the overall mean, and then the sample mean. Alright, so I have myself in a little bit of a jiffy, but that's okay. Essentially, based on the videos I watched, mu would be the 120, so that would be the population mean, and then x bar is the sample mean. So I totally said that wrong, so ignore that whole thing.
Okay.
That's a lie.
All right.
That is a lie. That is the population. Alright, we're changing the variables a bit. Okay, so mu is 120, which is the population mean. X bar would be all of these added together divided by how many there are, and there are 10 of them. So that would be equal to 1,297 divided by 10, and then that would equal 129.7.
Okay.
N is the number of values in the data set. That's the word. Look at that. He's got me. That is 10. And the sample formula, which is what we need to find, is the square root of the summation of x minus x bar squared over n minus 1. Does that make sense?
Yeah.
Cool. Alright, so now this whole section is going to be us finding the sample.
Okay.
Alright. So right here, the square root, this symbol is summation, x minus x bar. It's kind of hard to see that line. Let me make that darker. Squared over n minus 1. And so how do we find that, you ask? So I made a little table to help you out, okay? A little table. And so I put all the same values here to just make it easier to keep track of. And so what you do, x is the value, so it'll be 118 minus the x bar. And the x bar we calculated by taking the average, remember that? So we just simply do x minus x bar, x minus x bar, x minus x bar, so on, so forth.
Okay.
Keep it up, keep it going. And then you have to make sure you square each one.
Okay.
Does that make sense?
Yeah.
Alright, and so once you get all those values, you add them up and you get 1,453.1. And so then you plug that into the problem. So you see how I circled this in blue?
Yeah, and that's
And how
in blue
it's
too.
the same, yeah, it's in blue too. So that means that this value fits into the formula right there. So in case that while I was talking in that clip, it was going a little too fast for you, I'm gonna do it by hand right here so you're able to follow along. So once again, these are your x values, and the x bar is x bar equals 129.7. So you basically just have to plug them in individually. So for there and then there. And so we would be doing 128 minus 129.7 squared. 118 minus 129.7 squared. 144 minus 129.7 squared. 114 minus 129.7 squared. 132 minus 129.7 squared. 111 minus 129.7 squared. 149 minus 129.7 squared. 139 minus 129.7 squared. 136 129.7 squared. And the last one, oops, I accidentally put 2 parentheses there. Okay. All right, and now we're gonna put that into a calculator. So 128 minus 129.7 equals 1.7, or a negative 1.7 squared. And then we're gonna go through it and do all of the others. 118 minus 129.7 equals negative 11.7. I'm gonna make sure that was a negative, even though it doesn't really matter because the square cancels out all negatives. All right, and then you want to square them all. And when you square them, you should get these values. And you want to add all these up. And then you'll get 1453.1. And so what you do is then do the square root of that value over n minus 1. What is n?
10.
Yes! Beautiful!
Yes.
And then do 10 minus 1.
9.
And that would equal, yes, that would equal 9. And then when you divide those, it would be 161.45. And do you want to take the square root on a calculator of yours? Yeah, let's make him do a little work, you know.
Yeah, it does it with square root 161.45. That's gonna be, what decimal point am I rounding to?
What do you mean? A second. Sorry, I was like, what do you?
12.71.
Oh, beautiful! I didn't even have the
nice.
1, but I'll add the 7-1. And guess what? We're getting close to the end, and
That's
I
not
did
the
this.
end?
Oh no!
Jeez. Okay.
No, it is not
Whole
the
other
end.
page.
It's a half page.
All right.
And I'm supposed to be going up to 12 minutes, but I'm finishing earlier because you're such a great student.
So smart.
Okay. So now we have all the the values in the formula.
Yeah.
That makes sense, right?
Yeah, we got them.
You remember how to remember them all?
M, X bar, N, standard deviation. Yes.
Oh yeah. Okay. And so the formula is T equals X bar minus mu over S divided by, or standard deviation divided by square root of n. And so you just plug it in. Alright,
Yeah.
so 129.7 is X bar minus mu, which is 120, over 12.7 divided by square root of 10. And then actually, let me make you do it.
2.41.
You saw it?
Yeah.
You saw it. Okay. He's just so good at math in his head.
So
you know?
observant.
Oh yeah, so observant. So you got 2.41. And so, this is the part where I'm gonna actually need you to use your phone, and you're gonna need to look up a two-tailed t-test.
Two-tailed?
Oh yeah, just type in two-tailed t-test, or no, t-table, sorry. Excuse me, t-table.
Okay.
Alright, and in this problem, I give you, I believe this is called the alpha, that symbol.
Do I need to have a table in front of me?
Yes.
Does that look right?
I think so. Hold on. Yes,
Okay.
beautiful.
All right.
I'm going to teach you how to navigate that thing. Okay, so if you look here, I told you the alpha, which
OJ.
is 0.05. The OJ? What is that?
Oh, it looked like a J. It's a 5.
It's a 5, not a J. Okay, so alpha is 0.05, and then in order to calculate it, you need to know what the degrees of freedom are.
I see
So
the DF.
so DF is on that side, and then the alpha is on this side. So DF, the formula is n minus 1. What was n?
10 or something?
Yes.
Yeah, there it is.
What is 10 minus 1?
Oh, geez. 9?
Yep. Okay. So now you need to find where 9 and
Oh,
0.05 meet
Wait,
on
I
the...
got it. 0.05?
Yes.
Under 2 tails or 1 tail?
2 tails.
2 tails. Shanning. Stand by. Okay, I got it.
Alright, what is it?
2.262.
Excellent! So that is the T critical value. Alright.
Do I need this open?
No, you don't need that anymore since I have it written down. Okay, so now we are in the home stretch, Connor. Okay? So now we have to compare the T critical by the T statistic that we calculated. Because remember how this whole problem equaled to T?
Yeah.
So we notice that 2.41, our T statistic, is greater than our T critical that we found on the chart, which is 2.2 or 262. So we see that? You see that? Greater than?
This,
Yeah. So based on this, since it is greater and not equal Remember how we wanted the null?
Ooh.
Oh wait, where did she go? We wanted the null to be equal to wherever that is. Equal to. So since it is not equal and one is greater, we reject the null because it is not greater than, and we take the alternative hypothesis. So from all this, it appears that the blood pressure levels are different from the population average versus this 10 sample average. Does that actually make sense?
Yeah. Makes perfect sense.
All right. Thanks for a great semester, Professor.